Hello? Ah, that looks better. Okay, then I think we can finally start. Yeah, now I can hear myself. Okay. Awesome. Yeah, welcome to everyone in the chat. I saw there are lots of people already, which is amazing. And then we can dive right into the first part of this week's stream after I answered one of who was it? Saukari's question, and he asked about he asked for a video about important questions for an Hibernate interview. I would love to do that for sure. The issue there is I haven't went on a job interview for a while. So if you have any questions that you got during a job interview about Hibernate or JPA or other Java persistence technologies, please post them in the comments or submit them on my blog, and I'm very happy to do a video about it or a post on the blog. As I said, the only thing that's holding me back there right now is that I haven't done an interview for a while. So a little hard to come up with questions. Yeah, so let's get into the first part of this week's stream. Last Friday, I was asked for a stream about soft deletes. And well, that is something we can, of course, talk about. If you go to torbenjansen.com/live, you find all the past and the current live stream with a post for each one. And in the one for today, you will find additional resources that accompany all the things that we do today. You can find a direct link to it now in the chat. So soft deletes. What actually is a soft delete? Well, a soft delete is a remove operation that is actually not a removal of the actual data. So the idea there is that we replace the actual removal with more of a hiding feature. So that happens usually by adding an additional status flag to the database record and then excluding all the records that are marked as deleted from the actual reside sets in the application. And that has a few advantages. First of all, you can't lose data because you're not deleting anything. And then you can also offer a mechanism to your users that allows them to take back their removal operation. And you can include all these archived information in statistics, analysis, and these kinds of operations, which can be pretty beneficial. Okay, so let's get into the IDE and take a look at how we can actually implement something like this. So here I have a very basic example, and if you know the soft delete blog post that you can find on my site, then you might be already familiar with it because I used parts of it there. Yeah, Michael, I'm hiding the Hibernate tips book behind me. That's right. You can see that up there and in a few other places. So if you're looking for if you're looking for more information about Hibernate, then I highly recommend that book. And of course, all the free articles that you can find on the blog. Okay, so how does soft delete work? As I said, soft deleting a record means you're not removing it from the database, you're setting a flag, you're changing a status of the record, which identifies it as a removed record. And you can then exclude all the records from all the other reside sets of your database queries. So how do you do that? So the first thing we need to do is we need to replace the delete statement with an update statement, because with Hibernate's default setting, Hibernate would just delete the database record, and we don't want that. And you can change that by annotating your entity class with SQL delete. And then you can provide the delete statement here as one of the parameters that you, or attributes that you set on that annotation. So in this case, I update the account, a record in the account database, and set the state to deleted, which is an enum that I use within my application, where ID is the value of the provided bind parameter. And then I set the result check style to count, so that Hibernate knows how it can check if the actual operation was successful. So in this case, Hibernate would expect that the database tells it that one record was updated. Well, Hibernate thinks it was deleted. We know based on this SQL statement, it was only updated. Okay, so by doing this, we already made sure that Hibernate doesn't delete our statements or our records from the database. What we then need to do is we need to make sure that these records don't show up in any of our result sets of the other queries. So you could now include the state in all of your queries and make sure that you always check that you never use entity manager find, that you filter your associations when you retrieve them from the database. But that's not really realistic that this happens and that this gets implemented in all places of your application. So a more common approach is to also annotate your entity class with a where annotation, which enables you to add a where clause that will be added to all the statements that select account entities. So in this case, I check that the state is not equal deleted. And that's already all you have to do to make sure that the record doesn't show up in any results. So let's run this test and take a look at the result output. So what do we do in our test case? So here starts the test case. And you can see here that I first persist an account entity. Well, that works as expected. We set the bind parameter for the name and an ID. You can see here that we also set the bind parameter value for the second parameter, which is the state. Why do we do that? Well, this is an optional thing that I did here. I made sure that the state is always set. Where do I do that? State string. There, do that. What I wanted to mention is that it's also a pretty common approach to set the state as the state active as the default value here when instantiating a new entity object. You could set that here as a default value. You could do that as part of the constructor. That's a relatively common approach. In this case, I actively set my state to active to make sure that it is not equal to deleted and that the current status is tracked correctly in the database. So what's interesting in the next step is I get the account entity from the database using the name query account.findByName. Right, that is the query that I defined here. And you can see there is no state check in there, but there's one state check down here. So Hibernate adds that for a JPQL query. And then we can set the state, then we can access the state as a normal attribute. And after that, we can decide to remove the entity. And if we do that, and well, in this case, I call a flush, you would just commit your transaction. Then you can see that Hibernate executes the update statement that we added here. So this is the update statement that you can see down here when we actually delete the record. And afterwards, if we try to load the entity via Entity Manager Find, you can see that the result set here is empty, no longer shows up, because Hibernate again automatically integrates or adds the where clause that we defined via the where annotation to the query statement. So I saw there was a question in the chat about the about native queries. So the question there is, what happens if we do .create native query, select asterisk from account A, where a dot name equals name. And that is count class that we want to get back there. Okay. So the question is, what happens here? We execute a native query. Well, the easiest way to show that and to explain it is we just execute it. So we have a no entity found for query. What did I do? Okay, using a like expression would probably be beneficial. Yeah. And here you can see the query statement that Hibernate executes. That is exactly the query that we have up here. So to make it absolutely clear, the annotation, the where annotation that we added here doesn't have any effect on our native SQL statement. It only affects all the statements that Hibernate generates. And that, of course, includes JPQL statements, criteria API queries, entity manager find calls, and so on. But native statements are not handled by Hibernate. Hibernate takes this statement, treats bind parameters and stuff, but then sends that statement to the database without really changing anything on it. And that is one of the huge advantages of native SQL statements, because that enables you to use all the features supported by your database, and you're not limited to the feature set supported by Hibernate. But at the same time, that means that Hibernate can't add things like this additional where clause. Yeah, and that directly leads us to Alexandro's question, which is, how can we retrieve with Hibernate deleted entities for audit or history monitoring tasks? Well, using this approach, you no longer can't retrieve them as entities, because then Hibernate always adds this deleted check and, well, we exclude these records. What you could do is what we did here. You could use a native SQL statement and then just tell Hibernate, okay, I'm selecting entity classes by providing the entity class as the second parameter to the create native query method. And then you just get one or more entity classes back. Alternative 2 would be, second alternative would be you take a microservice-based approach. You have two applications with two separate persistence units. And in the second persistence unit, you have the same account entity, just without the where clause. The more common approach would be to use a native query for the use cases in which you need to retrieve the records that went through soft delete. And if you would want to revert the soft delete operation, you would need to execute a native SQL statement to change the value of the state attribute from deleted to active. Again, there you can't easily work with entities because the where annotation on the account class excludes them from all queries that you would execute. And therefore, you never get the account entity on which you would need to change the value of the state attribute. If you don't like that, then you could just remove the where annotation here and handle the filtering of all deleted accounts or deactivated accounts yourself by adding that to each and every query. That would be the approach that you would need to use with plain JDBC or any other framework that's closer to the actual SQL. There's another thing we need to take a look at, and that is the actual value of the state attribute. This approach here, which changes the state in the SQL during the SQL delete operation, this has a downside, and that is that if we go through this test case here and at this place, remove the author entity from the actual persistent context, then Hibernate doesn't know that we changed the state attribute in the database. It only knows that it deleted the entity and that it had to change its lifecycle state. So the update operation that happened up here never happened on the entity object itself. Well, if you immediately forget about this object reference here, because you're committing your transaction and you're just returning a result value to the API, then that could be totally fine. But still, it could happen that you still have a reference to this account entity, and there you would want to indicate that this record was deleted. And to do that, you would need to implement your own pre-remove lifecycle callback. But that's way easier than it might sound. You can see that here in the code. The only thing you need to do is you need to implement a method and annotate it with @pre-remove. And then Hibernate handles that for you, or also any other JPA implementation does that. So this defines a lifecycle callback when an entity object switches its or changes its lifecycle state from something to removed. Then this operation is executed before before this method here is executed. So what I do there, well, I write a short log message to tell that I changed the state to deleted, just to show that here in the test case, and then I change the state of that account, and that's it. So if we take a look at the log file, then we can see here that we see the set state to deleted log message directly before Hibernate executes our soft delete update statement. Okay, let's take a look at the chat. There are a few questions. So Borut asked, does JPA support the soft delete feature of Hibernate? No, not really. So here with this implementation, we are using several Hibernate-specific annotations. You can see that up here. So the SQL delete annotation and the where annotation are Hibernate-specific. And so due to that, this approach is Hibernate specific. Tepco asked if your JPQA statement already embedded a where clause. Does the where apply? Yes, it does. So here we have a query with a where clause. So here I'm comparing the name attribute using a like expression with the provided bind parameter value. And as you can see, where can you see it? Here. As you can see in the log, no, that's the wrong log statement. Let's run the test case again. This is still the native statement. Here it is. So this is the SQL statement that Hibernate generated for this named query execution. So that here is the named query that I defined on the account entity. You can see it here with the where clause that compares the name attribute. And then we set a bind parameter value, and Hibernate executes it. And as you can see here, Hibernate then adds the where condition that we defined and keeps the one that we set on the query. And William writes, always amazing tutorials and level of description. Thank you. Yep. Thank you very much, William. Thanks for the kind words. I'm doing my best to provide as much value in these streams as possible. And if you like streams like this and maybe want to have a custom or a dedicated stream at your company, then feel free to reach out to me. That's something that I started doing during this pandemic and doing on a regular basis with a few development teams, recurring live streams where we do some kind of teaching where we talk about projects that they have in their application. And yeah, feedback so far is really good and I'm enjoying it. So I will keep doing that for a while. Alexandru wrote, regarding retrieving with Hibernate, HQL, etc. of deleted entities, I saw in one of projects something like this. Native Hibernate implementation. Yeah, with a filter. Yeah, you could also use a filter instead of this where clause. That is also a Hibernate specific feature where you can define additional conditions that I applied when loading certain entity classes. And then you can activate or deactivate that filter in your application. That's also a pretty common approach. Ambrose asks, hi Thorben, will the entity class with deleted state still remain in entity manager cache or will it be evicted? That depends on the cache about which we are talking. So in the first level cache, we will remove the entity. So that means after we remove the entity, it's in state removed and it will disappear later on. In the second level cache, it will just stay there. And that means that you would need to evict it there either yourself or you wait until the cleanup process of your cache kicks it out, because it's to expected that an entity that you just deleted will not be used in the near future. So at some point, the cleanup mechanism of your chat will most likely remove it from the chat, but from the cache. But that's then specific to your cache implementation and its configuration. So Paul wrote, if you update the state and pre-remove, do you still need the set state in the SQL delete annotation? Would appear to be duplicate. Well, I definitely need an SQL delete annotation here that prevents Hibernate from executing the default remove operation, because otherwise I would change the state on the entity attribute to delete it, and Hibernate would directly afterwards remove the record from the database. And that would mean we don't have a soft delete. If you're triggering an update, no, I would still need the SQL update statement that I provide here where I set the state, because Hibernate thinks that it is removing a record from the database. So the only thing that it does is it takes the statement and sets the ID as the bind parameter value, or all primary key attributes. And because of that, Hibernate would never update the state unless it's part of the primary key, which doesn't make any sense. So yes, you still need the update statement where you set the state to delete it. Vinod wrote, is this soft delete works for delete queries generated by orphan removal true? I can't show this in this example, but yes, it works. And the reason for that is orphan removal and cascading of remove operation always works based on the same approach. Hibernate gets the child entities and then makes a lifecycle state change to delete it for each and every one of them. And that then triggers the execution of the entity-specific delete statement. And we override that statement here. So by doing that, we make sure that these records will not be removed and that they only changed their state from active to deleted. Yeah. Further questions about this? Okay. Then let's go on to our weekly recap section. And it would be great to hear what you think about this section, if I should keep it, if you like it or not. And yeah, how we should continue with this. So the content of this week, which is the topic of the weekly recap, what did we get? Instead of a new blog article in which I explain some new feature of Hibernate and stuff like that, I decided this week to address a question or a bunch of questions that I got over the last weeks and months. I was asked again and again and again questions about working with associations that are managed by JPA and Hibernate. So typical one-to-many, many-to-many association questions. And in almost all of these cases, I could quickly answer them by just sending a link. And that showed me that we need an overview page on the blog where you can find all these articles. And you can find that now at thorbenjansen.com/associations. You can see it here while I'm scrolling through the page. There are a bunch of articles about association mapping, starting with very basic topics like here an introductory guide to association mapping, to more complex stuff like working with ternary associations, so association between 3 entities, not just 2, or how to map to a Java utilmap. Few articles about avoiding performance issues and improving usability, something about fetching and best practices, and so on. So yeah, if you want to dive deeper into association mappings, make sure to take a look at that page. And then I uploaded a video about Spring Data JPA and especially native queries. It's the most flexible approach to execute queries with Spring Data JPA. And I explain all you need to know about that in this week's video. Okay. Then let's get into the question of the week. And that one is related basically to the page that I added this week. It's another question about association management. And here the thread opener had really strange behavior with their application. So there they had a parent and a child entity with a one-to-many, many-to-one association between them. And the strange thing was, when they moved the child from one parent to another parent, they got an exception detached entity passed to persist child. And well, I tried my best for a good while to reproduce the exception, because I was pretty sure that I know what caused it. But at least with the current Hibernate 5.4 version, you can exactly reproduce that exception, but you produce a different error, which probably is the same here. So if we look at the code, then we can see that they got the parent, the old parent, got the child from the list of childs of the old parent, removed it from that old parent, instantiated a new parent, and add the child to the list of children for that new parent. Did anybody see what is the issue here? So if you attended the stream about association mapping pitfalls, I think it was 2 weeks ago, then you probably have an idea what the issue is here. And the problem is that we set the association only on the parent entity. And if we take a look at the code, then this is the referencing side of the association, which is totally normal for one-to-many, many-to-one associations, because there we define the association on the many side, which means on the child entity. And by only setting it on the parent, we run into the issue that Hibernate might not trigger an actual SQL update statement. So that's what I explain here. The simple solution is this additional line that sets the new child as, the new parent as the parent of the child object, which then forces Hibernate to execute the SQL update statement that persists the information in the database, and that ensures that all the information are stored in the database, which is especially important in this case because on the child entity, they activated orphan removal, which would trigger a removal of the child object if it's not associated to any parent. So especially important here to make sure that you update the association on both ends. So I'm going here to remove the child from the list of children on the old parent. I add it here to the list of children of the new parent, and then I switch the two parents on my child entity to make sure that it's updated there as well. And that then ensures that everything works as expected. Comment here that I also posted on Stack Overflow is it's a little bit strange that we have orphan removal true and cascade type all on the parent, and then an additional cascade configuration on the child class. So cascading and orphan removal is something that we use with parent-child associations where the child really depends on the parent. And if we have these associations, we usually don't want another cascading of merge and persist operations from the child to the parent, because we already said that the parent is the defining entity, the one on which we perform our operations, and the one on which the child depends. So if you see something like this in your code, please take a critical look at it run a few test cases, and double and triple check that it does exactly what you expect it does. Here, this is obviously a simplified example, so I can't look at the business code and actually validate that this cascade definition makes sense, but I'm skeptical. I would say that is probably something that they should revisit and then validate with a few extra test cases. Okay. Then let's go to the Ask Me Anything question. I see that NipaFX already had a question. Yes, what about the poster? Yeah, that's something that Nikolai and I talked about in the chat before the stream started, and that is a poster that we both like, obviously, and that is from the Commit Strip comic, was part of the book. By the way, if you guys don't know NipaFX, make sure to visit nipafx.dev. So his username here, .dev. He makes amazing streams and blog posts about plain Java. So if you want to learn more about the JDK and all its fascinating features and what's coming up in the future, make sure to check out his YouTube channel and blog. Okay, so any further questions? No, Nikolai, you don't get your poster back. That's mine. Okay. Looks like there are not a lot of questions today. Above questions. Yeah, did I miss any questions in the chat? I did my best to already answer all of them during the... Oh, Nasa, I'm sorry. Yeah, I missed your question. So a while ago, NASA already asked how to handle lazy exceptions when I have 3-layer class. So NASA, I expect you have a persistence layer, so with entities and repositories, and then you have a business layer and then an API layer, or how is your application structured? If that's the case, then it depends on how on what kind of exception occurs and how you want to handle it. So there are quite often exceptions that happen in the communication between your business code and the database that are relevant for the execution of your business logic, and that you are able to handle there. If that's the case, then I would always handle them in the business logic. Make sure that everything works as smoothly as possible, and return them to the client. If it's an exception that can't be handled by the business logic, for example, because it was... Well, a record was supposed to be returned and was identified just by its primary key, and that one doesn't exist. Then you can just return the error to the user, or things like you have a concurrent modification on an entity. So the user's trying to update something that was already changed by someone else. In that case, you would need to return an error message to the client, and well, that is something that then totally depends on your application and API design, and is a little bit outside of the scope of JPA and Hibernate. so there the general rules of good API design apply. So make sure that you don't leak too many internal details. It can sometimes be hard with error codes and exceptions. Then make sure that everything is documented and that the information that you provide to the client, especially in an error scenario, are actually useful. So that is something you always need to put some thought into. When you're reporting the error to the client, you don't want to share all nitty-gritty implementation details where the exception occurred, but you also want to provide a few more information than, well, this didn't work, right? So try to make the exception as useful as possible, but keep it on a business level, not too much on a technical code level. I hope that pretty fuzzy suggestion helps. Yeah, so if I missed any other questions, we had a lot of conversations during the soft delete part in the chat. So if I missed anything there, please post it again, and I will do my best to answer it. So a question from Hibernate: what's the best way to implement native query pagination in Spring Data? Well, on that topic, I definitely recommend taking a look at this week's video. And this is this week's Spring Data JPA native query video. And I will now go to the post. That's probably a little bit easier. So what you would need to do is, and that is explained here in the article, you need to write a little bit of extra code. So pagination with Spring Data JPA is something that usually is pretty simple. So with a JPQA query or with a derived query, you just add a parameter of type pageable, and Spring Data JPA handles everything else. That doesn't work that way with native queries, because there Spring Data JPA can't easily create the count query. That would be way easier with the JPQA query. With a native statement, that doesn't work. So what you need to do is you need to provide a count query. And you can see that here, my getAuthorsByLastName method has a parameter of type pageable. And the query annotation has native query set to true. So here we have a native query for which we want to use pagination. This is the native query statement that I'm executing in this example. And the count query is then an additional parameter you need to provide to the query annotation. And there you provide the native SQL statement that Spring Data JPA can use to count the total number of results that shall be that are returned by the query if we don't use any pagination. And based on that and the pageable object, Spring Data JPA can then provide all these paging mechanisms that you know from JPQL or derived queries with Spring Data. Svetoza wrote, hi, I have a question on how to combine inverse auditing with batch updating with criteria API. Yeah, that is a problem. So if you're using batch updates by the criteria update, via criteria update operation, then you need to make sure that your update, that you write all the audit records yourself. And that is because Hibernate Envers mostly consists of a few lifecycle listeners that react on entity lifecycle changes. So when an entity object changes its lifecycle state to during an update operation, or if that object gets removed or inserted, then these listeners get triggered, and Hibernate Envers can track this change and write the audit information. So when you're using a criteria update operation, then you don't have any entities on which Hibernate performs any operations. So there are no events that get triggered. And based on that, we don't have any audit records written by Hibernate Envers. So what you would need to do there is you write your update statement using a criteria update, and then you write a few native insert statements that write the corresponding records to the audit table. That is usually so complex that it doesn't make a lot of sense to work with a criteria update operation, at least not if it's a operation on a huge data set that then performs more complex changes. If it's something simple, then yeah, you can handle that using native insert statements for the missing audit records. If it's something complicated, it usually doesn't work that well. Then you might want to look into a total custom implementation of that use case. Sakam wrote, what is the best way to implement optimistic locking using JPA and to handle locking exceptions? Optimistic locking, first of all, is based on a versioning mechanism. So you add let's take a look at the code. I'm pretty sure I have an example here where I update something. Yeah, here I might not have an update operation here, but I definitely have a versioning mechanism here. Yeah, so optimistic locking is basically this. You have an additional attribute on your entity and a column on the database, which is usually called version, and in most cases is a small int. And Hibernate increments the version number automatically with each and every write operation. And that is a feature defined by the JPA specification. So you can use that with each and every JPA implementation. And that is all you need to do to get optimistic lock. So now the next question is, how do you handle optimistic lock exceptions? And these occur if you have two operations that run in parallel, in two parallel transactions, and try to update the same database record. And then Hibernate loads the entity, keeps it in local memory, and when it writes the update operation to the database, it compares if the version value in the database is still the same as the version value in the entity object that you got earlier from the database. And if these two version numbers differ, then Hibernate throws an optimistic lock exception. And my general recommendation is to not handle this exception at all. From a technical point of view, you could handle it. And you will find articles online where people show you how to use a servlet listener or an additional service layer that catch this exception and trigger a retry of the same operation. And that is something that I don't recommend in general, because the concurrent modification that was detected by the optimistic lock exception is something that we need to handle very carefully. It means that we had two operations that changed the data. of that record. So if we just do a retry and maybe are lucky enough, and well, you could also say not lucky, you're missing a few checks, but let's say this update operation works, then we would change all columns of mapped by that entity object. And that means we override the change that created the optimistic log exception just in the previous iteration, several milliseconds ago. So we're losing an update operation that we just executed. We can't do that. What we would need to do is, if we catch the optimistic log exception, we would need to get the current version of that record and the one that we got from the client, and then merge that somehow on a semantically meaningful level and write that record to the database. Well, good luck with that. That's not something that I would like to try. If you say that you can automatically merge these two concurrent modifications, then yeah, a servlet listener, for example, would be a good approach if you're using a REST API to catch the exception, merge the two versions of the record, and then trigger the same operation again. But that is something that is so complex that I would always recommend to show the exception to the user and tell them, look, I'm sorry, there was another user who updated the same record. Please take a look at the current version of that record and apply your change to it. And that is something that most users easily accept, because it's very easy to explain to them that they need to take a look at the data that they are working with, and they need to make sure that the change that a coworker did almost at the same time works well with the update that they did, and that this shouldn't be handled by some part of the application that somehow magically merges that into a new version. So far, I've never seen an end user who was very keen on having such a magic algorithm mess around with their data. So as I said, my recommendation would be let the user handle that. Show them an error message, maybe help them with good UI design, and let them handle that. Nasser asked, what's the topic of next week's stream? We will talk about auditing with Envers. That was another request from last Friday. If you have topic suggestions for these live streams, feel free to post them in the chat during the stream. I collect them and I pick the topics then for the following weeks. And next week will be about auditing with Hibernate Envers. So we will dive a little bit deeper into what we talked about today. And we will definitely take a look at the two query APIs that Hibernate Envers provides, where you can look at the changes performed on one record over time as the vertical view of your audit log, and on the horizontal view where you go back in time to a certain date, let's say the 31st of December, and then you look at the data that you had there that was used to create the last set of invoices or something like that. Hibert wrote, there's other way to get count without executing one more query. Native query pagination question. No, I think that the only way with Spring Data JPA to use pagination, at least if you want to use the Spring Data's standard pagination feature. No, I don't know of any other approach there. As far as I know, you always need the maximum number of records that are included in this result set. Vinod asked, is it required to use Spring Data JPA find by ID for an entity that has a natural ID, only ID annotation? And Second question, is it required to get an entity which has natural ID, only ID annotation, using find by ID in Spring Data JPA before saving? No, it isn't. So if you define a natural ID on your entity, then, right, it's still an entity object as any other object that doesn't have a natural ID. So what you can do there is you can use any finder method you like to get the entity object as a managed entity. That could even be a native query. And then you can change any attributes on that, and that's all you need to do. You don't even need to call the save method. At the end of the transaction, when you commit the transaction, or when Spring commits the transaction for you, Hibernate will automatically flush the current persistence context to write all pending changes to the database. And while it's doing that, it takes all the entity objects that are currently managed and compares them with the version that it fetched initially from the database. And as soon as one of the attribute values differ between the original version and the version that you worked with, Hibernate recognizes, okay, there was a change, so we now need to write an update statement. And then Hibernate writes the update to the database, the transaction gets committed, and hopefully everything goes well. And then the change shows up in your database and is persistent. Okay, I think I answered all the questions that are currently in the chat. Again, if I missed someone, please post it again. I don't intentionally ignore any questions in the chat. So as I said, if I missed something, please just post it again. Okay. Then I think we reached the end of the stream. I'm waiting a little bit longer if there are any additional questions. If you want to take a look at the additional material that I prepared for today's stream, then please go to thorbenjansen.com/live. There you can see a post for each and every live stream that we did this year. And if you go to the one from for today, you can see the embedded live stream video here. A few minutes after I end this stream, this will be the recorded video. And then you can find here additional resources, links to the article and the video of this week, and a link to the Stack Overflow question that we talked about, a few more resources on the stuff that we did there, an article about the soft delete that we talked about. And you can find this for each and every live stream that I do. And yeah, as I said earlier, topic for next week will be auditing with Hibernate Envers. If you have any topic suggestions for future streams, please post them here. Join my email newsletter and reply to an email there, or post them as a comment on the YouTube channel. And then this might become the topic of one of the following streams. Yeah. Next week, stream will be again at 3 p.m. CET, so same time as today. I wish everyone a great and relaxing weekend. Stay healthy and see you next week. Bye.